Google just released Nano Banana 2 Lite, our fastest, cheapest image model yet. It can draw complex architecture diagrams in under 3 seconds. But if you are using it to generate visuals for your tech stack without auditing the code, you are playing Russian roulette. We ran it against our own build-and-show codebase, and it completely hallucinated the logic. Today, we compare the 3 tiers, Lite, Flash, and Pro, and show you how to detect their silent architectural bugs. We will look at why speed does not equal accuracy, and how to verify that your diagrams match reality. Released on June 30th, 2026, Nano Banana 2 Lite, officially known as Gemini 3.1 Flashlight Image, is built for high-throughput, low-latency applications. It is designed to replace the legacy version, cutting API costs by 60% and generating images nearly 3 times faster. Google achieved this by using distilled neural architectures and optimized weights, allowing developers to generate hundreds of drafts for the cost of a single standard run. However, this speed comes with a significant trade-off in detail resolution. In the google-genai SDK, the 3 tiers are laid out by latency and cost. Lite gets you a draft in 3 seconds. Standard Flash takes 11 seconds. And Pro takes 23 seconds. Crucially, all 3 Nano Banana models are multimodal. This means you cannot call them using the traditional generate_images endpoint. Instead, you must invoke the generate_content API with an image modality configuration, passing the response modality settings explicitly. This changes how server-side developers track tokens and compute costs. Early developer feedback is highly polarized. While teams love the raw speed and low metered costs for batch prototyping, critics are calling out major text rendering bugs. Small fonts frequently blur into illegible blocks, and technical terms often hallucinate characters. This is because the compressed autoencoders in these models are optimized for speed, which causes fine details, like line intersections and small text, to lose structural clarity. To put these claims to the test, we grounded our prompt in the actual architecture of our build-and-show code compiler. In this repo, a curriculum planner writes module briefs, parallel AI subagents write individual HTML sections, and a simple shell script uses a basic cat command to concatenate them into index HTML. The subagents never touch JS or CSS. Let's see how the models drew this compiler and whether they respected our HTML-only constraints. Let's audit the Lite tier first. The diagram correctly mapped the 4 compiler stages and avoided generating JS or CSS. But look at the header. It spelled Curriculum Planner as CRRM Planner. This is a classic text rendering slip caused by character approximation. Furthermore, the model suffered from prompt leakage in the legend, rendering our visual style guidelines directly as legend items. If you copy this diagram into a pitch deck, it screams AI generated. Standard Flash is visually stunning, but it fails on multiple levels. First, it labels every subagent output as HTML, CSS, and JS. In our codebase, agents are strictly forbidden from writing JS or CSS. Flash hallucinated a common website template pattern instead of respecting our actual code. Second, it duplicated the subagent mappings, showing Agent 2 writing Module 2 and Agent 3 writing Module 2, dropping Module 3 entirely. This logic loop would break the build. Nano Banana Pro got the architecture completely right, showing agents writing strictly HTML code. But even Pro has a blemish. In its decorative code boxes, it rendered garbled pseudo tags like coda and soda instead of code and section. While it is the only diagram that is structurally flawless and presentable, these minor text blemishes prove that even premium Pro models are not immune to character hallucinations. This audit reveals the one-shot diagram trap. AI models generate images in a single pass without verification. They excel at drawing clean templates, but they fail to verify system logic. They constantly omit return paths, representing databases and caches as write-only sinks, and drawing arrows that bypass application servers. If you do not catch these bugs, you risk documenting broken architectures. If you need absolute precision, skip text-to-image generators entirely. Our channel's best practice is to write clean, minimal HTML and CSS templates of your diagrams and capture them programmatically using headless Chrome. By setting fixed viewport dimensions like 1200 by 590, you get perfect, crisp typography, and zero logical hallucinations. You control the exact data flows. Here is our final verdict. Use Nano Banana 2 Lite to draft concepts in under 4 seconds when you need to brainstorm. Use Pro for high-level minimalist visual slides, but always run a close visual audit to catch spelling errors. And for detailed production specifications, skip image models entirely and build your diagrams using HTML and CSS templates with headless Chrome screenshots. The entire comparison utility script and the raw diagram assets are open source in our Build and Show repository. Clone it, run your own prompts, and tell us which model won in the comments below. Subscribe to Use AI with TechDad for more data-backed developer deep dives, and keep building.